Hi everyone. So in this video we're going to be talking about pyrimidine biosynthesis and clinical considerations, and truly we're only going to be talking about the synthesis of UMP, mostly because the other pyrimidines are not super important because they're not super clinically relevant and therefore they're not relevant to medical school education. Also, the salvage and degradation pathways of pyrimidines are also not super clinically relevant, so we're not going to be discussing them in this video. So the first step of pyrimidine synthesis is the synthesis of carbamoyl phosphate. And the way we're going to create carbamoyl phosphate is we're going to take glutamine, utilizing an enzyme called CPS2. And what we're going to do is we're actually going to push in CO2, also utilizing 2 ATP. And we're going to get out our 2 ATP, obviously, glutamate, and an inorganic phosphate. So what is happening here is that we have this glutamine, and glutamine is actually acting as our nitrogen source in this case. So we have that amine group on glutamine, and we're utilizing the CO2 to push off that amine group, and we're essentially replacing it with the CO2. So that's how we're going to end up with glutamate. And additionally, we're adding an inorganic phosphate from one of our ATP, and the other ATP is utilized as just an energy source, as ATP usually is. I do want to take note here that there are multiple enzymes called CPS. Obviously, if we have a CPS2, we also have to have a CPS1, right? So the difference being is that CPS2 is mainly working in the cytosol. And obviously we know that it's using glutamine as its nitrogen source. It is creating carbamoyl phosphate, and CPS1 actually does create carbamoyl phosphate as well, but it uses ammonia as its nitrogen source, and also is occurring in the mitochondria. And it's really important in the creation of urea, whereas CPS2 we're using to make UMP, right? Just know the difference between those two enzymes. The only really real reason I'm bringing this up is because later in your education, you're going to learn about this enzyme, and I just don't want you to get confused. So, carbamoyl phosphate. The next step is we're going to take aspartate, combine it with carbamoyl phosphate, and aspartate is going to eventually, after a series of steps, create orotate, also known as orotic acid. And from there, orotate can go on to create OMP and then eventually UMP. So our first step from orotate to OMP, we're actually going to be adding a compound known as PRPP. And if you watch my other video, you will know that PRPP is important in a number of different things, first of which is being purine and pyrimidine biosynthesis. And obviously we can see how it's involved in this step, so we know it's important for our pyrimidine synthesis. If you watch my other video on purine synthesis, you'll learn how it's important there. It's also important for purine and pyrimidine salvage pathways. Now, I did tell you that we are not going to be discussing the salvage of pyrimidines, but it is important to know that PRPP is involved in that. Additionally, I did discuss the salvage of purines in my other video, so please go look at that as well. And then the last thing that it does is it is involved in the creation of NAD from tryptophan. And so obviously whenever we are pushing PRPP in, we're going to be kicking out those pyrophosphates. We're going to have 2 inorganic phosphates resulting from that. The enzyme that does this reaction is called orotate phosphoribosyl transferase. And down here, we're going to have another important enzyme called OMP decarboxylase. And what's going to happen anytime we have a decarboxylase, we're essentially going to be kicking out a CO2 because we're decarboxylating it, right? So why am I telling you guys about these specific enzymes? So we have CPS2, orotate phosphoribosyl transferase, and OMP decarboxylase. Well, CPS2 is a really important enzyme because it has allosteric regulation. So it can actually be allosterically activated by PRPP. So that is another role of PRPP. And if you remember from my other video on purines, you know that PRPP also acted as an allosteric activator to glutamine phosphoribosyl amidotransferase. So please go review that video if you don't remember that. But also, CPS2 is going to be negatively regulated by UTP. And that's pretty common. A lot of times our products will go back to inhibit our beginning stage enzymes to prevent the synthesis of whatever we're trying to create, right? So we're making UMP. I mean, this is going to easily be converted to UDP and then UTP, and then UTP is going to be the one that comes back and inhibits CPS2. So these other enzymes don't really have allosteric regulation. Obviously, this one, if PRP is not there, you're not going to be able to do that reaction. However, mostly these enzymes are important because they have a special clinical consideration. The deficiency of either orotate phosphoribosyl transferase or OMP decarboxylase results in a condition called hereditary, orotic, aciduria. And what's happening here is we're actually going to end up with a buildup of orotic acid because whenever we don't have these enzymes, right, we can't push things to UMP, and therefore we're just going to be kind of stuck at orotic acid, and we're going to keep synthesizing this because of that. And that has a lot to do with the fact that, right, we're not utilizing PRPP. So now we have this positive regulation up here to CPS2, and we're just going to keep pushing stuff forward. So whenever we have this buildup of orotic acid, we are going to be excreting a lot of it through the urine, hence the aciduria. But another thing that's going to be happening is we're going to actually end up with this severe anemia. And this is a really common effect to anything that inhibits DNA synthesis. So if you remember, folate and B12 as another example are really important in the creation of DNA. And if we don't have folate or B12, we actually end up with something called megaloblastic anemia. So yeah, that is pretty much an overview of pyrimidine synthesis. Super short, a lot easier than purine synthesis. If you guys have any questions, feel free to leave a comment, and I'll get back to it as soon as I can.